notacon.
Good afternoon. My name is Mike Tetrault. I'm going to speak to you on threat modeling. Originally, my presentation was going to consist of two parts, threat modeling and a demonstration of what happens if you don't mitigate the threats. Unfortunately, I managed to pretty much destroy the virtual machine that I had planned on using as a demonstration by using Retina against it and cranking it up just a little too hard. So instead, I'm going to be doing a little bit more expanded presentation on threat modeling and the threat modeling process. I guess the best way to introduce it is what it is. Simply put, it's a framework for improving the security of applications and infrastructure. It provides a way of analyzing what are the threats, what are the risks against those threats, and what are the consequences if those threats are not mitigated. What it is not. What it is not is, it's not a silver bullet. It will not fix all of your security woes. It is not the holy grail of security. It's several steps in the right direction, but taken by itself, it's not sufficient to mitigate all risks. Traditionally, security has fallen to the backside after analysis and design have been done, and after code has already started, people start thinking to themselves, wow, maybe we should consider security of the application here. And by that point, it's either too late or too expensive to put it in for those things that do need to be mitigated. It's cost prohibitive. By doing it up front and by baking it in as part of the process, it makes it much easier to swallow rather than having the fire drill at the end, or worse, after it's already out and released and having a vulnerability put out on you. This presentation is solely an introduction. The actual process itself is very involved. The process, as outlined, is fairly extensive and really can't be covered even in a two-hour session here. What I'm going to give you today is the benefits and a high-level overview of what it does. But as far as the how, that's something that you guys need to research on your own. Let's talk a little bit about traditional security analysis, how it's done. The typical way is you have your annual rate of occurrence times your single loss expectancy brings about your annual loss expectancy. Basically, that's how often it'll happen, how much you will lose when it happens equals how much you will lose per year from it. Unfortunately, that doesn't take a lot of things into account. There are things that simply can't be quantified in that. Damage to reputation. If a financial services company has a online brokerage site that gets hacked, that's obviously going to be a lot more costly than the financial losses incurred and the regulatory penalties assigned for it. There's going to be a tremendous loss of consumer confidence in that company. Another traditional tool is the code review. I don't know how many of you guys are developers within the corporate realm, but those of you that are have almost undoubtedly been through the code review process for at least some of your code. They're slow, they're tedious, they're moderately effective in most cases. Some cases they're not effective at all. It comes down to you have to be able to figure out what code is it that you need to analyze and look at in depth. You need to focus the efforts on those pieces, not lose sight of anything, because if you lose track of even one line of code within those critical components, you can leave a very serious vulnerability in there. One example of why a code review is not an effective tool by itself is looking at an authentication mechanism. What a code review can tell you about looking at your authentication mechanism is whether it is secure or not, and whether it performs securely inside of itself. What the code review cannot tell you, however, is whether the security level of that code, the authentication code, meets the needs of what the application has. That's a byproduct of the code review not being an integrated part of the process. What threat modeling does is it integrates the code and the security requirements into a cohesive unit to allow for managing the entire process. Another failing of the code review is that it's not really appropriate for infrastructure level code. Code reviews are really best for very small, very defined, very critical structures within code. State machines, session handling, things like that. Places where an attacker is going to try to subvert the code. Where it's not so good is in dealing with large infrastructure type things. You have hundreds of thousands, if not millions of lines of code in core applications. There's simply too much there to be able to effectively go through in a code review, no matter how large the scope of it is. An example of this is looking at a session handler. A session handler has security requirements both within the context of an application and within the context of itself. In doing a code review, you're typically only going to be looking at it within the context of itself. You'll be overlooking architectural issues such as having identifiers that can be guessed, which would allow you to predict who the next person is going to be. I believe it was the Guess Genes website had predictable identifiers, and basically people were able to view other people's information on them, and they ended up getting a very severe fine from the FTC, and they actually have ongoing monitoring of their internet operations. They have to have them reviewed by the FTC for, I believe it was 20 or 25 years. I don't know how long that's going to hold up, but that's what was originally imposed. Obviously, they were spanked pretty hard. Another thing that a code review is not going to find is a replay vulnerability. If I know what somebody else's session identifier is, if that request is not authenticated, then I can pretend to be that user. A code review is not going to, you're not going to have the requirement come out of a code review or have it enforced that all requests be authenticated. That's an infrastructure thing. That's something that's simply outside the scope of most code reviews. Another type of attack that would likely escape most code reviews is injection. Basically, by putting in arbitrary code to a session identifier, you can potentially, assuming it's not boundary checked, have expose a vulnerability within your database engine, for instance, if that's where your state session is kept. One of the failings of code review in that would be that even though boundary checking may be in place, what would not be in place is a knowledge of what is the state engine going to be behind the scenes there. What is it that this particular session server needs to be on the lookout for to keep out of the state engine. What code review tools can tell you is whether or not a string is being operated against without having the boundaries checked first. That's very simple for any of the automated code review tools out there to do. One of the things that's more difficult for them to do is to identify an overflow because a function is looping and copying into that string. If that string length is a fixed length, I'm not aware of any code review tools out there that will automatically catch that. Classic buffer overflow in action right there. Application security lifecycle. Basically, we have 7 steps here. The steps feed one into the other, although some of the steps will feed back into previous steps. It's not just 1 to 2 to 3 to 4, so on and so forth. As we discuss steps that feed back to each other, I'll point that out to you. Beginning with gathering requirements, that's where the security work of an application needs to begin, is at the very upfront stages. By having security be a consideration in the process from the requirement stage on forward, it's much easier to make changes to affect the security of an application. If something is found to be unsecure, or if it's not secure enough, it's very easy to make a change at this stage of a project to increase or change the security to a level that it needs to be. Once you're into implementation and deployment, obviously the cost is much, much higher. Some of the considerations that you need to take into account when gathering requirements as far as security goes are what is the deployment environment? Is this something that's meant for the small office or home user, or is this something that's meant for corporations, or is this meant for an organization that has higher security requirements than that, something like a military application, for instance? You need to keep in mind who your audience is for the product in order to effectively drive security requirements for it. Customer expectations. Customer expectations are also very important as well. If it's a product that's being pitched as a security product, you better have your product secure. If the app is responsible for critical business infrastructure, obviously, if your application is going to be put into, is serving a need that is a critical underpinning of a business operation, it's going to be one of the first places that hackers are going to go after. Another consideration is it widely deployed? Is this something that only a few thousand people would have use for, or is this something that's going to be the next Microsoft Word? If it's something that everybody's going to be using, what type of files do you use? Are the files that you use within the application generally regarded as secure, like JPEG files? I'm sure most of us are aware of the GDI vulnerability in the JPEG handling. One final consideration on this is whether the product is being positioned as being more secure than the competitors. That's up to those marketing people. Who knows what they're going to do. But if they do start saying that, you better make sure that it is more secure. And in order to do that, you have to get the security baked in up front.